Alright guys, the following video is meant to accompany the worksheet for Friday, so this is the worksheet for Friday. You can download it in the lesson on Google Classroom. I'm going to go over the mini lesson, so these three questions here, 1, 2, and 3. The remainder of the worksheet is up to you to do, but the point of this is so that you can kind of learn the lesson at your own pace. You can pause and rewind as you need to, answer the few questions in the Ed puzzle to get full credit. And when we come into class on Friday, you will complete this do now assignment, and then we will work on the problems on the back. So the goal is that we just do the problems on the back. We'll have already done the problems from the mini lesson in advance. We might even finish class early, but let's get started. Firstly, writing proofs using the definition of a parallelogram. So the definition of a parallelogram is that there are a quadrilateral with two pairs of parallel sides. So we are purposely trying to prove other things we know. We're going to try and use information that is given in order to prove that a quadrilateral is a parallelogram. So in this case, we are told that angle 1 and angle 2 are congruent to one another, and we're also told that angle 4 is congruent to angle 3, and that is given. And they wrote them in the same statement, which you can do. Here I'll actually write given in black, and I'm going to write 3 and 4 in blue, and 1 and 2 in red, just so we can see them on the graph more obviously. Now, if angle 1 and 2 are congruent, we can say that AD and CD are parallel. We get this classic Z shape. This classic Z shape is an indicator that using this transversal, these lines must be parallel because of the converse of the alternate interior angle theorem. And because these two angles also form this classic Z shape, meaning if we made these lines appear parallel using this transversal, they are also congruent for the same reason. Now, ABCD will be congruent, will be a parallelogram by the definition of a parallelogram. Because we've discussed what the definition of a parallelogram is. We've now stated that there are two pairs of parallel sides. They are both part of the quadrilateral. Therefore, it is a parallelogram. All right. Let's move on to the next proof. We're told that AD and BE bisect each other. So those happen to be the diagonals, AD and BD. So the diagonals bisect each other, which is one of the properties of a parallelogram, which means we should be able to prove that this is a parallelogram using the definition of a parallelogram if we just try to work towards that goal. All right, now we're going to be writing the statement involving the segment bisector in this line. Now you'll notice we have two segment bisectors. They bisect each other. So we're going to say that AC is congruent to CD. And we're also going to say that CB is congruent to CE. Because they bisected each other, so they're both bisectors of each other. So the definition of a segment bisector is the accurate reason for why those parts are congruent. Next, they tell us that angle BCA, which if we look at the diagram closely is over here, is congruent to ECD, which is over here. Why are those congruent? They are vertical angles. Now, if you look closely, these two triangles have several parts that are congruent. So we should be able to say that the two triangles are congruent for a particular reason. What triangle congruence criteria would prove that these two triangles are congruent that we have established here based purely on the two diagonals bisecting each other? You should have said SAS. Now that we've proven that those two triangles are congruent, we can say all their other parts are congruent by CPCTC. So next we're going to look at angle ABC, which is over here, and it's congruent to angle DEB, angle ABC is going to be congruent to angle DEC, or B, either way, and that's because they're part of those triangles, so that is CPCTC. So because they're part of the two congruent triangles, we can say that those angles are congruent. Now, if you look at those angles carefully, those angles are part of our classic Z formation. So if they're part of the Z formation and they're congruent, that's going to make this line and this line, using this transversal, parallel, which is half of the definition of our parallelogram. So we're going to say AB is parallel to DE. Next, because these angles, ACE is going to be a vertical angle to DCB, these are also two congruent triangles, also by SAS. So these were vertical, making these triangles congruent by SAS. So AEC, which is over here, will be congruent to angle EBD in the other triangle. So EBD. By CPCTC, because we've proven those two triangles are congruent. And it makes our another one of our classic Z positions, or images. So that makes this side and this side parallel using this transversal, because these are alternate interior angles. So the reason is going to be converse of alternate interior angles, making sides AE and BD parallel. Did I say AE? Yeah, AE and BD are parallel by the converse of alternate interior angles, which allows us to state that ABCD is a parallelogram. I'm going to use this as a shorthand for parallelogram in the future, drawing what looks like a parallelogram with a little p inside to imply it's a parallelogram. The reason will be definition of parallelogram, because it has two pairs of parallel lines. All right. Next, it says we have a parallelogram BKJN. So if we draw a parallelogram BKJN, we're told that angle K is 70 degrees. You should be able to find the remaining values on your own. So I will end the video here. Having gone through these proofs, there will be a few more proofs for you to try on your own. If you need help, we'll be going over them in class. So all of these questions we'll be going over in class. All right, so I hope you did well on this Edpuzzle, and I will see